Hi guys, how are you doing? Today I'm going to discuss about amino acids. And amino acids are quite common in our food, daily products which we eat, from vegetables or fruits, meat, and it's really important if you're a biochemist or if you're learning stereochemistry or doing peptide chemistry. You first start from the amino acids, and proteins are also made up of amino acids. And furthermore, it has quite huge importance in stereochemistry or chiral chemistry as well, because mostly amino acids are chiral, having one or two chiral centers present in them, except glycine, which is not chiral. All other amino acids are chiral. So let's start with the definition of amino acid. So this is a carbon, and there is an R group, and this is acid, and this is NH2. So because of this means carboxylic acid group, which I'm going to say blue color, NH2 groups. That's why they are called amino acids. So this is NH2 group, is amino group, and this is acid. So acid, NH2, amino. So amino acid. If there are more, that's why we say amino acids, plural. There are basic 21 amino acids, naturally occurring 10 non-essential and 10 non-essential, and you need to understand which are positively charged amino acids, which are negatively charged amino acids, which have hydrophilic or hydrophobic side chains, and some amino acids are aromatic. And let's start. And there are codes of amino acids, 3-letter code and 1-letter code. So I will discuss those codes with you also. Okay, so the first amino acid is arginine, which I'm going to discuss here. Arginine. So if we go to Chemdra and convert, this is arginine, the structure of amino acid. So you can see there's a chiral center, that's why it's a bold line here. And again, this is acid group, and this is amino acid group, that's why this is amino acid. And the name of this amino acid is arginine, and the 3-letter code often you see in protein chemistry, that is ARG, used for arginine. And also there's a unique code for every single amino acid, that is a 1-letter code. So you call, like periodic table, you say C. If you see C in periodic table, you call it carbon. And if you see 1-letter code here, like R is a 1-letter code for arginine, and 3-letter code ARG for this one. So it has 2 codes, and we will discuss the pKa value of the pKa value of this OH is 2.03, and pKa value of NH2 is 9.0. If you don't know about pKa is the acid dissociation constant. It gives you idea about how strong or weak the acid is, or the group is. So higher the pKa value, lower the acidity. So for example, if we decide which is most acidic, this NH2 or this OH, so we will look for the number of pKa. If you see here, in all cases, so the lowest number is first one, that is this one, and it has value of 2.03, and this is acidic, most acidic among all the other two. So let me write here. By the way, I will delete immediately, erase this whiteboard, So you can watch this video and pause it if you want to note down the structure or pK values meanwhile. And also, if you haven't subscribed my channel, please subscribe this channel, like it and share it for more videos. And also I got a request from my friend, and he was saying that my videos are of advanced level for MPhil and PhD students, but this video about amino acids is for basic students of college chemistry or BSc level honors, and particularly for biochemists. This is the first video they should watch, because this is from where the biochemistry starts, from amino acids, and the stereochemist also. And I'm going to use in-depth analysis of amino acids, not just putting the names like arginine, glycine, histidine, aspartic acid. No, I'm going to explain the pKa's, the classification, the charges, the letters, the codes, everything in this video. It's a perfect complete video about amino acids you will ever see. I hope so, at least. Okay. Okay, this is the point which I was mentioning, that lowest pKa means highest acidity of that group, or higher the pKa value, lower the acidity. Okay, so keep this thing in mind, so in order you can quickly pick which side is most acidic and which side is least acidic. So this is most acidic and this is least acidic. Okay, so this was the arginine, having 3-letter code ARG, 1 letter is R, and this has a charge, that is positive charge on NH2. So we call this amino acid as electrically charged side chain. So there are 3 amino acids which fall into this category, which have charged side chain. Could be positive or could be negative. So if there is a positive charge, we call them a positive, doesn't matter, positive electrically charged side chain. So there are 3 amino acids: arginine, histidine and lysine. Let's discuss about histidine now. Histidine. Okay, so if you convert this into this structure, this is the structure of histidine, and histidine is the name of amino acid. The 3-letter code for this histidine should be his, and the 1-letter code for this amino acid is H. So H is 1-letter code, H, and HIS is 3-letter code. Okay, now next thing we will discuss the pKa's. The pKa about, this is 1.70, and pKa of this is 9.09, and pKa of this is 6.04. By the way, pKa and acidity is a quite big concept in organic chemistry. I will try to make a comprehensive video about acidity of organic compounds. There are number of factors: resonance, hydrogen bonding, electronegativity. But here, if you are not familiar with the acidity or pKa values, just roughly I'm telling you, acid groups are more acidic and basic groups are more basic. Like NH2 is a basic group, so it's more basic. This is carboxylic acid having acid group OH. It's going to be more acidic than NH2 group always. Doesn't matter what the pKa's are. Anyway, if you have a data like here, you have pKa value of 3 positions, you can simply look at the number. If the number is lowest, that group is going to have highest acidic character. If the number is highest, that group is going to be lowest acidic. Okay, again this is a positively charged amino acid. Positive charge is on this nitrogen, and this is positive electrically charged side chain, histidine. Okay, and the next group of this family of positively charged amino acid is lysine. So this video is important for peptide chemistry students as well. So this is lysine. Lysine has a 3-letter code that is LYS, and it has 1-letter code is K. If I write from this data RHK, so you, by looking the 1-letter code, you can find out that this is a sequence which contains amino acid sequence which contains arginine, histidine, and lysine, and these are positively charged amino acids. They are not neutral, they are not negative, they are not hydrophilic, whatever. And all these amino acids are chiral. Here is the chiral center, 1 1 1. Okay, lysine, 3-letter code is LYS, 1-letter code is K. Now the pKa of the most acidic will be this. Now you know this, and the pKa will be 2.15, and pKa for this will be 9.16, and pKa for this will be 10.67. okay, and now we have to put the positive charge. Okay, so now this is positively charged amino acids. So these three are positively charged amino acids: arginine, histidine, and lysine. These are the 1-letter code for them, RHK. These are the 3-letter code, ARG, HIS, LYS. Okay, let me erase this because I'm running out of the area. Okay, if you haven't watched the video, if you haven't subscribed yet, please subscribe and pause the video if you want to note down the structure of these amino acids. Okay, now the next group is negatively charged amino acids. One is aspartic acid, this, boom, here is the aspartic acid. So this amino acid contains 2 acidic groups. One is this, and this is a basic group, NH2. Okay, and the negative charge is here, and yeah, 3-letter code for aspartic acid is ASP, and the 1-letter code for this is D aspartic acid. By the way, amino acids could be D and L, don't forget about this thing. Okay, what is D and what is L, leave it for another video, or you can ask me in the comments below in this video. I will try to answer your questions. pKa for this is 1.95, pKa for this NH2 is 9.66, and pKa for this negative charge oxygen is 3.71. okay, so from pKa you can clearly say this is most acidic group, then this one, then this one. That order will be this. The next amino acid in this family is glutamic acid. So so this is glutamic acid structure. Again, this contains 2 carboxylic acid group, 1 carboxylic acid, another carboxylic acid, and NH2, and it has 1 chiral center here. Okay, lovely. Now next, the 3-letter code for glutamic acid is GLU, and the 1-letter code for glutamic acid is E. done. And now the pKa value for this acid group is 2.16. pKa for this NH2 is 9.58, and pKa, oh, there will be a negative charge on this oxygen, that's why we classify them as negatively charged amino acids, and the pKa will be 3.71, and this is most acidic because it has least lowest pKa value than the rest of these, and this is most basic, this is most acidic, this is intermediate. Okay, so these two are the amino acids which are negatively charged, and they have a 2-letter code. If you see a sequence DE, so D stands for aspartic acid, E stands for glutamic acid. That's it. These are the 3 and 1-letter codes that you often encounter when you do peptide chemistry or protein chemistry. Now the next class is amino acids with polar uncharged side chains. Like we discussed positive and negative, now we are discussing the group of amino acids which have polar uncharged side chains. Okay, and the first member in this family is serine. So serine is amino acid having this structure. Okay, so if you haven't watched my functional group video, please watch. So there are 3 functional groups in this: acidic, NH2, amines, and alcohol. And there's a 1 chiral center obviously here, this one, and the 3-letter code for serine is SER, and the 1-letter code for serine is S, and the pKa for this acid is 2.13. pKa is 2.13, and pKa for this NH2 is 9.05, and the next is threonine. Amino acid in this family of polar uncharged groups. Why this is they're polar? Because this is an OH group, this is polar, and this obviously acid and NH2 are already polar, and they don't have any charge, neither positive nor negative. Okay, next is threonine, amino acid of this family of polar uncharged amino acids having okay, selected. Okay, this is threonine again, having 2 chiral centers, 2 chiral centers, and no charges. It's polar uncharged side chains. Threonine has THR 3-letter code and T as the 1-letter code. The pKa for this acid is 2.20. The pKa for 8.96. Okay, so acidic and basic. Next group in this family is aspargine, and if you can it into name, here is the structure of aspargine. So the 3-letter code for aspargine is ASN, and 1-letter code for aspargine is N. So if you can't remember the whole amino acid, so you can remember S, T, N, and they belong to polar uncharged side chains. And one more, that is glutamine, I will discuss in a moment. Okay, now let's put the pKa. This is aspargine having pK value of 2.16, and this is NH2 having pK value of 8.76, and that's it. The next amino acid is glutamine, GLU, glutamine. So Okay, and this is glutamine, GLN, and its indication is Q. So we can, the 1-letter code is Q and 3-letter code is GLN. And this is polar uncharged amino acid having amide functional group on one side chain, unlike, okay, asparagine also had amide functional groups as a side chain. So pKa for this acid is 2.18 to be very precise. pKa for this amino acid is 9.00. so these are the 4 amino acids: serine, threonine, asparagine, glutamine. So S, T and Q. 4-letter code for these 3, and they are polar uncharged, having polar uncharged side chain. Okay, next is third class of the second class of the amino acid is special cases. Okay, so we put them in special cases because they don't have any charge, positive or negative or polar thing. Like, they do have polar groups, but for the sake of classification we put them in special cases. This is how they are classified, of course not by me but by the people. Okay, cysteine, cysteine. Cysteine, these are amino acids which make proteins, and they are naturally occurring amino acids. They are necessary for us. We eat them, and we can't buy like from the vegetables. Just can't eat a part of cysteine, but they are ingredients which are found in naturally occurring fruits, vegetables and so on. They are sources of protein, like proteins are made up of amino acids. Okay, cysteine, the pKa of this acid is 1.91, and the pKa of this NH2 is 10.28, and pKa of this SH is 8.14. and the 3-letter code for this amino acid is CYS, and the 1-letter code is C. The next amino acid is SELEN, seleno cysteine, selenocysteine, which is belonging to this category, having selenium, Se. That's why it's seleno, because of selenium element. Selenocysteine pKa is 1.9, and pKa of this NH2 is 10, and glycine, another amino acid, and this is the only amino acid which is the simplest one and does not have any chiral center. This is the achiral. So this is the alpha carbon, and alpha carbon contains NH2 group and acid group. That's why these are also called alpha amino acids, because they are connected via alpha carbon. Okay, so pKa for glycine's acid group is 2.34, and pKa for this is 9.58. Glycine, that is GLY, and the 1-letter code is G. Next amino acid is proline. It's amino acid which does this thing, proline, and this amino acid has pKa value of 1.95, and this is secondary amine. If you have watched my video about classification of functional groups, then I have classified these I mentioned that how we can classify amine. So the 3-letter code for this is PRO, and the 1-letter code is P. Okay, proline P. That's it. These are the 4 amino acids. So we can put them as, okay, by the way, I haven't mentioned, sorry, I forgot to mention here, the selenosystine is second if you want. So U is the shortcut, a 1-letter code. So C U G P. If you remove comma, if you see these 4 letters connected, reading a biochemistry book or protein book or research paper, if you see this sequence, this means these are the amino acids having 1-letter code. So you, in order to decode them, so C stands for cysteine, U for selenosystine, F what am I doing here? G is glycine, and P is for proline. Okay, now next move to further situations, next level amino acids, that is those amino acids, this is those class, a big class amino acid that contains a hydrophobic side chain, and one of them is alanine. So alanine is this, it has 3-letter name is ALA, and 1-letter code is A, and the pKa for this is 2.33, and pKa for this is 9.71. Okay, so this is 9.1, and this is this. So this is alanine having the 3-letter code of a pKa of 9.71, and this, and also we have a next amino acid is isoleucine, which is hydrophobic chain. By hydrophobic, you can see this methyl group there. There's no polar, not charged, nothing, so you can say this is hydrophobic. Right? Okay, so now let's move on to the next amino acid. Video is getting longer, but I don't have any other solution, to make it short. Do give me your suggestions. How can I improve isoleucine? So we say ILE, and it's denoted with I believe, yeah. Isoleucine, and okay, let's see the structure. How is structure? So it's gonna have NH2 group, acid group. Oh god, what am I doing? Delete this. Select, then convert. Okay, here you go. Now you see this is the hydrophobic part, that's water repelling part. This part does not like water. Say for example, insoluble in water, right? That's why it's hydrophobic. Next is ILE, 3 code I, and the pKa for this area is 2.26, and the pKa for this is 9.60. Leucine. So next amino acid is leucine. So what is into this is leucine amino acid having the 3-letter code U and 1-letter code L. So when you have a pKa of this is 2.32, and Okay, 9.58. The next amino acid is methionine. There are so many unnatural amino acids, and we are talking about natural amino acids. Okay, so methionine has 3-letter code T under the code N. We can read of this is 2.16. pKa of this is 9.08. 9.08. Yeah, this is a hydrophobic part. Next amino acid is tryptophan. No, let's focus the phenol. Benzene and this part is hydrophobic. Two-letter code is one-letter code FF. pKa of this is 2.18. pKa for this amino acid is 1.59. Next is tryptophan. Okay, now these are the hydrophobic, so we classify into negatively charged amino acids, positively charged amino acids, polar uncharged amino acids. Those amino acids hydrophobic, which in some special cases only amino acids which are not glycine. If we are amino acids chiral, all amino acids have 3-letter code, all amino acids have 1-letter code, acidic, acidic, pKa amino acid. Okay, let's do a quick short method how to memorize amino acids or how to figure out the sequence of all the amino acids. You see R that is okay, let me write all the amino acids in one letter so that would be easy for the RH K to E, then S to N Q C U G P A I L M F W V. Okay, so now R is equal to ARG, H is equal to histidine, arginine, K is equal to lysine, D is equal to ASP, and P is equal to GLU, glutamic acid, S is equal to serine, T is equal to threonine, THR, and N is equal to asparagine, that is ASN, and Q is equal to glutamine, that is GLN, and C is equal to cysteine, that is CYS, and U is equal to cysteine, that is SEC, glycine is equal to GLY, and rho-NP equals to PRO, then A is equals to alanine, that is AAA, isoleucine is equals to I is equals to isoleucine, that is IIE, a capital I, then next is leucine is equals to LEU, and methionine is equals to M, that is MEG, and then F is equals to phenylalanine, W is equals to tryptophan, TRP, and tyrosine is equals to Y, that is TYR. The last one is V, that is valine. Easy guys. So these are the 21 or 20 amino acids. Total list: 1 letter code, 3 letter code, and I will discuss the pKs and the structure of each amino acids. So again, this is acid NH2 amino acids pKs. I hope you like this video. Please subscribe this channel, and this was basic video for biochemistry, organic chemistry students and peptide chemistry. Feel free to put your comments below, like and share my channel, and press the bell icon for more videos. Thank you, bye, see you.